NixOS. Let's see what's in the config.
October 2023. A user posts asking for guidance. They have already made 10 unbootable switches, 10 separate rebuilds that left the system unable to boot. Each time, boot from install media, enter recovery, attempt repair. The rollback existed the entire time. The boot menu showed previous generations. They did not know. Not a failure of the technology. The rollback works, not a failure of the principle. The declarative model is the strongest in this comparison, a failure of the gap between what the system can do and the knowledge required to use it, created as a doctoral project at Utrecht University. The 2006 thesis. Treat software packages as pure functions. Same inputs, same outputs always. 20 years later, companies building on it, a governance crisis that ended with the creator stepping down, a community fork, and a learning curve that has not gotten shorter. The most capable and most frustrating distribution in this comparison. Eelco Dolstra's doctoral thesis at Utrecht University in 2006 described the core insight. Software deployment has the same problems as mutable global state in programming. Packages modify shared system directories, create implicit dependencies, and make it impossible to guarantee that software installed on one machine behaves identically on another. The solution was to treat packages as pure functions. A package is a function from its inputs, source code, dependencies, build tool versions, compile flags, to its output. Same inputs produce the same output. The outputs live in a content-addressed store in paths named by a hash of their inputs. Two versions of the same software coexist without conflict. A package's entire dependency tree is captured in the hash. Dependency conflicts become structurally impossible. The operating system applies this model to the entire machine. Kernel, bootloader, services, users, packages, configuration files, all described in a single declarative specification. One command applies that specification. The same file produces the same system anywhere. Rollback means selecting a previous generation from the boot menu or running a single command. The commercial ecosystem now includes companies building installers, developer environments, and deployment infrastructure on top of the thesis. The package repository is one of the largest in existence, maintained by the community. The cross-platform capability extends the model to the other major desktop operating system through a separate tool and manages user-level configuration through another. No comparable alternative exists in the distribution ecosystem for describing an entire computing environment in code across multiple platforms. The store corruption documented in November 2023 is the most severe technical failure. The verification tool found missing derivation paths. The database that tracks the content-addressed store had foreign key constraint violations. The recovery required manually deleting broken derivation paths and editing the database directly. Understanding what a derivation file is and how the database relates to the store is not beginner knowledge. This is a failure mode that no other distribution in this comparison shares. The reproducibility caveat was documented in April 2024. The system guarantees that the same inputs produce the same build outputs within its model. Bit-for-bit reproducibility, where the actual binary outputs are identical across different build machines and times, is a stronger claim that is still in progress. For users whose concern is consistent environments across machines, the weaker guarantee is sufficient. For users whose concern extends to software supply chain verification, the distinction matters. The modern workflow uses a feature that has been formally experimental since 2021, but is now the community's expected approach. Documentation is split between the older channel-based approach and the newer approach. A newcomer in 2026 navigates both simultaneously. One documented assessment states the experience without the modern approach is horrible. The user-level configuration tool that manages dot files and application settings adds another layer of setup that users encounter immediately after installation. The configuration language is unlike anything they have used before. The module system merges option definitions in ways that are not obvious. The gap between installing the system and understanding it well enough to configure it correctly is larger than for any other distribution in this comparison. Spring 2024, a defense contractor became a project sponsor. A portion of the community objected. The dispute escalated into broader governance concerns about board authority, moderation practices, and leadership concentration. Board members resigned. On April 30th, 2024, the creator of the project stepped down from the board. A constitutional assembly was convened. A new governance structure was established with a steering committee alongside the foundation board. A community fork of the core tool emerged in 2024, representing a subset of the community that wanted a different development direction. As of 2026, both the original tool and the fork exist. The community is still rebuilding. The community split follows the same pattern documented in the Silverblue research, but at a different level. Users who left describe the learning curve, the configuration friction, and the documentation gaps. Users who stayed describe it as the only system where they can describe their entire environment in code, carry it between machines, and reproduce it exactly. Both the thread from a user who left and the thread from a user approaching a year of use describe accurate experiences with the same software. The difference is whether the user's investment in learning the system reached the point where the model's advantages outweigh the ongoing friction. The community that remains is technically sophisticated, committed to the model, and willing to accept that the cost of admission is higher than any alternative in this comparison. If you have decided that treating your operating system as a reproducible configuration artifact matters more than ease of use, and you are willing to invest weeks learning a configuration language, a module system, and a workflow that has no equivalent elsewhere, the system delivers on its promise more completely than any alternative in this comparison. The rollback model is the strongest available. The package model eliminates dependency conflicts structurally. The declarative specification produces the same system on any machine that receives it. The per-project development environments provide isolated toolchains without polluting the system. The cross-platform capability extends to the other major desktop operating system. No comparable alternative exists for describing an entire computing environment in code, except that the learning curve is the highest in this comparison by a significant margin. 10 unbootable switches is a documented newcomer experience, not an exaggeration. The configuration language is unfamiliar. The module system is non-obvious. The documentation is split between two incompatible approaches. The gap between installation and competent configuration is weeks, not days. Accept that the store database can corrupt, and that recovery requires knowledge that newcomers do not have. The verification tool can identify problems. Fixing them requires understanding derivation files and database structure. This is the most severe failure mode specific to this distribution. Accept that the governance crisis is recent. The creator stepping down, the community fork, and the constitutional restructuring are events from 2024. The long-term trajectory depends on whether the new structure stabilizes. Accept that reproducibility means inputs produce the same outputs within the model. Bit-for-bit identical binaries across different build environments is a stronger claim that is still in progress. If your concern is consistent environments, the guarantee is sufficient. If your concern is supply chain verification, understand the distinction. The comparison with Silverblue is categorical. Silverblue is the accessible entry point with an escape hatch that undermines its own model. This system is the uncompromising implementation where the model works fully but demands the user learn it fully first. Silverblue breaks when you modify the base. This system breaks when you do not understand the language describing the base. Both break. One breaks because the escape hatch blocked the upgrade. The other breaks because the user did not yet understand what the rebuild command would do to the boot chain. The cost is real. The payoff is real. The system that produces the same machine from the same file on any hardware is the system that requires the most investment before it produces anything at all. The distribution where dependency conflicts are structurally impossible is the distribution where the configuration language is the hardest to learn. The capability and the friction are the same thing.